Alright, now what we're going to talk about today are functions. Now, functions we've kind of already talked about a little bit with our function families, but today I want you to kind of think about functions in a different aspect. So, if you're thinking of a function, maybe even our function family, say a quadratic. Okay, it looks like a quadratic, it acts like a quadratic, so right now we're going to consider this a quadratic. But let's say that we have something that looks a little different than a quadratic. So maybe this way. Okay. The problem with this and why this makes this not a function is this right here. If we have an x value of 1 and you're trying to find what your y value is at that point, well, it's either this point right here, which maybe is 2 or 3, and this point down here that is, say, negative 2 or 3. Now, we can't have that. That is kind of our big no-no. So, our general rule to make a function is our x has to equal 1 and only 1 y value. So for every x value, there is one and only one y value. So in this one, there's 2 y values for this one x value. So this is not a function. This is a non-function. Okay, let's look at another one that we can tell is not a function right off the bat. Okay, boom, circle, or kind of an oval shape. Okay, right off the bat, we can look at a few different points. So right here, say this is 1. Well, it has a y value up here. It has a y value down there. Okay, so for this x value, it has 2 y values. That means this is not a function. Again, it's a non-function. And this is why a function cannot have more than one y value. We're going to write a function like this. F of x equals, let's just say 4x minus 3. And if I want to find what that x is, or that f of x is, I have to plug in a value for my x. So I say I want to find what does f of 3 equal. Well, that's just asking me what does my y equal when x equals 3. Okay, so this is my x. I'm just going to replace it with 3. So 4 times 3 minus 3. So I have f of 3 equals, this is 12 minus 3. So f of 3 equals 9. Okay, so that's all well and good. This is my x value. If I'm only going to get one y value out of that, which is 9, okay, so that's why this is a function. Because I plug in one x value and I get one y value. We can also see this in many other types of charts. So right here we have a t-chart right here. We're going to see this x value, I get one y value. This x value, I get one y value. So really what you're going to go through here, you're going to look and make sure if they have any doubles. So right here we have a double x value. Okay, and on this double x value, we have 2 different y values. So that is saying that when x equals negative 2, we're actually going to have 2 different y values. And that means that this is not a function, because it cannot have more than one y value. Another way you might see this, so we have 1, 2, 3. Let's do 4, 5, and 6. Okay, so this one's saying when x is 2, y equals 4. X is 1, y equals 6. X is 3, y equals 5. Now that right there would be a function. The only thing you have to look for in this one is, again, the doubles. So if 1 is also 4, then this is not a function because 1 cannot have 2 outputs. So it is also a non-function. Alright, the last thing you're going to see when you see these types of problems is this right here. It's a set. Oops. A set of mixed numbers. So we have x and y values. Let's do one more. Alright, so for every x value right here, I can tell you this is a function because I don't have any repeats. So whenever x is 4, y equals 2. Whenever x is 3, y equals 4. Down and so on and so on. When x equals 1, y equals 0. Okay, so on and so on. Okay. Another thing that I need to point out, it does not matter if these numbers repeat. The y's can repeat all they want. But as long as the x's don't, then we have a function. So if we have, that's an ugly 4. If we have more than one x value can equal 2. So if all these things equal 2, that is fine. That is a function. If you plug in 4 for your x and it equals y, if you plug in 3 for your x and it equals y, you plug in 2 for x and it equals a y of 2, that is perfectly fine. That is still a function. The only problem is whenever an x value equals more than 1. So in here it equals 2 and it equals 3, that's when it would not be a function. Okay, so that's enough about telling me whether a graph or a set of numbers is a function or not. Now I want you to actually evaluate the function. So if I give you a value for x, in this case, I need you to tell me what my f of x would be. So if I tell you that this is your function, and I want you to find f of 4, you need to be able to plug this in. All I'm doing is whenever there was an x, I'm changing it to 4. Oops, I forgot my squared sign up there. Okay, so that's the only thing that's going to be different. So I have f of 4 equals, well, 4 times 4, because 4 squared is 16, plus 2 times 4 is 8. So f of 4 equals 24. Alright, and that would be my final answer. As long as I know how to figure that out, I should be good. Okay, evaluating is not terribly difficult, it's just substitution. So we're plugging in whatever value I give you right here for x into over here in these values of x. So let's look at a couple more examples. Again, it might not always be f of x. Okay, it might give you something like this. Let's go with this. Okay, and I tell you that g equals -3. Well, all I'm going to do again, plug in that -3 for x. Plus 2. So g of -3 equals, remember you're going to do what's inside the parentheses first. So 3 times, well, that's just -1. So g -3 equals -3. Simple stuff. Alright, and now I want to show you one that might be a little bit more difficult, but I think we'll be able to figure this out. Alright, so here's a problem that, hint hint, is probably going to be on your homework, probably going to be one of your harder problems that you'll have. So if you pay attention, you actually watch this video, you'll probably know what you're doing, and it'll probably give me a little hint as to who actually watched the video or not. Okay, so all you're doing again is plugging in this value for x. So every time you see an x, you're going to put x plus 2. Okay, if it was at the end, if there was an x on here, we would again put the x plus 2 right there, but since there's not, that's all we got to do. Okay, now x plus 2 squared is going to be a little bit different. Hopefully you guys have done this last year so that you know that x plus 2 squared is just x plus 2 times itself, right? Just like anything squared is times itself. Okay, we have to add that plus 4 on the end. Alright, and this is just distribution. So x times x is x squared. 2 times x is 2x. 2 times x is 2x. 2 times 2 is 4. And again, bring that last plus 4 down the end. Now we are combining like terms. So g to the x plus 2 equals x squared. Combine these two like terms. Combine those two like terms. And we have our answer. Okay, remember, if you're putting this into the computer, that's going to be a little up caret x to the raised to the power of 2 plus 4x plus 8. That would be the answer put into the computer form. Alright guys, come to class tomorrow ready to go, and hopefully you watched the video and hopefully it was helpful. If not, come to class and we will do plenty of learning.